Students, last class we have learnt errors, different types of errors. Now today I am going to teach you combination of errors. It is otherwise called your propagation of errors. Combination and propagation of errors. Let us understand what is the meaning of it and how it is useful in our calculation or measurement. Suppose we are calculating a physical quantity, like some physical quantity, they are calculated by indirect means. They are measured by indirect method. Suppose, let's say, calculate the volume of this room, or let's say there is a rectangle. Find out the area of the rectangle. It means you need to find out the length as well as breadth of the rectangle, and you have to multiply that to physical quantity. Means suppose let us calculate the area. Area is given by length into breadth of a rectangle. This two you are going to measure, and this A means the area you need to calculate. So these two are measurable quantity and this is a calculated quantity. So while measuring this length and breadth, there may lie some error. So the error of measuring in length and breadth will definitely appear in the case of your area, because it is calculated on basing on the measurement of length and breadth. That's why the error of the measurement of length and breadth part is carried to the calculated value of your area. That's why that is called your combination of error or propagation of error from this measured value to the calculated one. That's why we need to know how to deal with this kind of measurement. Basically, we will see there are three varieties of combination of errors. And the first type is error in a sum or a difference. Suppose there is a physical quantity Z that will be calculated by the sum of or the difference of two physical measured quantity, like A and B. Means Z is equal to either A plus B or it may be A minus B. For both of this, A and B are actually the measured values of that physical quantity, and while measuring we can report the result of A. That means measured value of A will be A plus or minus del A. Similarly for B we can write A plus or minus del B, and in the final result of this calculated quantity also we can report in the same manner, means the true value with the error part. So here A is the true value of this physical quantity A which is measured here, and delta A is the error part. Means your measured value, that in the last class I have already told you, in the measured value is most likely to lie within A minus del A and A plus del A. That's why the value is written in this form. So here A represents the true value of the measurement of A, and delta A is the absolute error what lies there. Similarly for B, and here it is for Z. So your rule number 1 is suggesting if a physical quantity can be found out by adding two other measured physical quantity, or their difference gives you this quantity, then the rule is suggesting the entire absolute error in this calculated value Z is nothing but the sum of the absolute errors in the measured quantity. Means if Z is equal to A plus B or A minus B, then the absolute error in Z, it will be denoted by delta Z. So total delta Z means absolute error in Z is the sum of absolute error in A plus sum of absolute error in B. We can prove this in a simple method. So let me prove for Z is equal to A plus B. Similarly you can prove for Z is equal to A minus B. So these are the values what I have taken here. A is equal to A plus or minus delta A, means the measured value will be written in this form. A is a true value plus or minus the error part. So as I have taken, let Z is equal to A plus B. So the measurement value, the measured value of Z can be reported in this way. Means, so the true value along with the error part, it may be a +1 or a plus, or it may be a minus. That's why I took Z plus or minus delta Z is the measured value of your, or the reported value of this physical quantity. Now A, we know A is equal to A plus or minus delta A. So I have just substituted the value of A here. A is equal to A plus or minus delta A. So don't be confused. A is a measured value, which is reported in this way. It is actually the true value. You can put a bar over here. You can also put a bar over here. So no confusion here. Means Z plus or minus delta Z is given by A plus or minus del A plus B plus or minus del B. So both the values I have just substituted. Now I can write this Z plus or minus delta Z is equal to, now you can just take out the bracket. So which is A plus B. A plus B I kept it one side, plus this delta A plus this delta B I put it in other bracket. Now you can compare LHS and RHS. You are going to get Z is equal to A plus B, means if here it is a true value, then definitely A plus B will be the true value of that measurement. And actually your value may differ, means your measurement value may differ from that true value. So that's why the measured value or the calculated value, here we can, if you compare, here A plus B is equal to Z, here it is Z, means Z got cancelled, and we are going to get delta Z will be given by delta A plus or minus delta B. So which is our, what the formula is suggesting. How this formula is applicable? Let us solve one question, so you will be very clear about it. So remember the formula. If Z is equal to A plus B or A minus B, then this is the formula. Suppose there are two resistances given. Two resistances given like this. Suppose R1. R1 is equal to 10 ohm with an error of 0.1 ohm. This is the R1. Let R2 is another resistance whose value is 5 plus or minus 0.2 ohm. It means what? R1, the value, the actual value may lie between 10 minus 1 means 0. Means your 9.9 ohm to 10.1 ohm. So means the measured value of your R1 or the calculated value of R1 will lie within this range. So here that 10 is the true value, 0.1 is the error part. Similarly for R2. And suppose they are connected in a series grouping. Find out the total resistance. The question is find out the total resistance. We know the formula in series grouping. Your series resistance is equal to the sum of R1 plus R2. Now as we know RS is equal to R1 plus R2, and we know the formula here, then the total error, if we calculate the total error here, or the value if you find out the resistance, so the true value will be added. You see 10 plus 5, 15 plus or minus, see the error here it is 0.1 and here it is 0.1. So to calculate the error part, the formula is suggesting in our result the total absolute error is the sum of absolute error in both the observations. So here the absolute error is 0.1, here it is 0.2. So the total absolute error is 0.3. So this is the case of your resistances in series. Suppose someone might have asked you calculate the difference between the resistances. Difference between the resistances, what is the difference? R1 minus R2. Then your answer would be, see the true value, here it is 10 and here the true value is 5. You just subtract the true value, it is 5. Then we will go to the error part. Now here, since to calculate the error, we need to apply this error in a difference. The formula for error in a difference. For difference also the same formula is applicable. Means the total absolute error is the sum of absolute error in both the two cases. So the difference, the true value is 10 minus 5, which is 5, plus or minus. Here the error is 0.1 and here the error is 0.2. So the total error will be 0.3. So this will be your reported result. So that will be the case of your sum, error in a sum or a difference. here don't be confused. Whatever be the formula here, it may be a plus or maybe a minus. Remember all the time, while calculating the value, true value will be added or subtracted according to the question. But the error part, error is always added. It won't be subtracted. Clear? That is the main part here. Now you come to the second formula. Second formula that we can say error in a product or a quotient. Error in a product or a quotient. That first part is the error in a sum or a difference. Now comes to your error in a product or a quotient. The formula here it is Z. Z is a quantity that may be the product of A and B or maybe the quotient of A and B. So the formula is suggesting that. So while dealing with the error part here, if this will be the formula, Z is equal to either A plus B or A divided by B, then the relative error in Z, the total relative error in Z will be the sum of the relative error in A plus or minus the sum of relative error in B. That we can prove. Clear? So let us take, I am proving it for Z is equal to A into B. You can find it for A by B. Suppose Z is equal to A plus B. Now as we know, the reported result can be, the value of Z will lie between Z minus delta Z and Z plus delta Z. That's why I have written the value here. For Z, I am writing Z plus or minus delta Z. This is the true value and this is the error part. So which is the product of these two? And we know A is given by A plus or minus del A and B will be given by B plus or minus del B. Now you multiply. So I have mentioned here that is Z plus or minus del B, it is remain as it is. Now you just multiply by opening the bracket. A into B, A into B, A into del B. So plus or minus as it is plus or minus A into del B. I kept it here. Now delta A into B means B into delta A, this part. The last part is plus or minus delta A into delta B. I kept it. So 4 terms are here. Now what I did, in both the sides I divided one Z. In both the sides here let us divide one Z here, this side, and one Z this side. So after dividing I am getting, see, Z by Z it is 1 plus or minus del Z by Z. Now comes to here, A into B divided by Z plus or minus A into del B divided by Z plus or minus B into del A divided by Z plus or minus delta A into delta B divided by Z. Got? As Z is equal to A into B. As we know here, Z is equal to A into B. So you substitute on the right side of this equation, Z is equal to A into B. Now in the right side, left side remain as it is, 1 plus or minus del Z by del Z, what I kept here. Now you take Z is equal to A into B. So A into B divided by A into B, which is your 1. Now A into del B. So instead of this Z, I can write A into B. So A got cancelled. So I can find del B by B, what I kept here. Similarly, here if you replace Z to be A into B, B got cancelled. So which is your del A. Here B got cancelled. So the value will be del A by A here. Similarly, you can put A into B. So the last term I can keep del A by A into del B by B. So here 1 and the right side it is 1. So 1 got cancelled. And see here, now you can find del Z by Z is equal to del A by A plus del B by B plus del A by A into del A by B. This term is very small in comparison to this term, so it can be neglected. So del Z by Z is equal to plus or minus del A by A plus or minus del B by B. So the formula is suggesting so the relative error in the measurement of Z is the sum of the relative error in A and relative error in B, which is our formula. Now let us solve a question related to your error in a product or a quotient. Suppose you are given your voltage, the measured value of the voltage is given in this way, 100 plus or minus 5 volt. and your current is given by 10 plus or minus 0.2 ampere. Find out the resistance in that circuit. We know the formula R is equal to V by I, voltage divided by the current. Now you see here, as our formula is given, here you are asked to calculate the resistance, means you need to report your resistance in this form, means the true value as well as with the error part. See here, since R is the quotient of V and I, so we can apply the second rule, means while calculating the relative error in R, we can write here delta R by R. Delta R by R will be given by delta V by V plus delta I by I. That is the maximum permissible relative error in the measurement of your R. Delta R by R is equal to del V by V plus del I by I. Now we need to find out the data from there. See, and we can calculate the true value of R is a ratio of true value of voltage with the true value of your current. The true value is of voltage your 100 volt, and the true value of your current is 10 ampere. Means if you find out the true value of R, this R is your true value, then there is simply V by I, which is 100 by 10, which is equal to 10 ohm. But now your relative error we can calculate, which is del R by R is given by del V by V. Del V is what? The error in the measurement of your voltage. The error is your 5. Means del R by R is equal to 5 divided by V. V is your true value, which is your 100, plus del I by I. Del I is the error in the current, which is your 0.2, that is absolute error. Delta, that is 0.2 by I. I is your true value, that is 10. Now this will become, so which implies del R by R will be this. We can take LCM, which is 100, so which is 5, plus if you take the LCM and divide the 10 into 0.2, it is your 2, so which is 7 by 100. Got? So if someone will ask you to calculate the relative error in the measurement of R, your answer would be 7 by 100, means 0.07. But here it is asked to report the result of your R, means you need to find out this value of your delta R. So which implies here delta R is given by 7 by 100 into your R. So 7 by 100 into R is how much? We have calculated is 10. Now you can calculate, so which will be your 0.7. Now you can report your result. We know the reporting the result. So R is equal to R plus or minus delta R. Ideally this should have written delta R plus or minus delta R dash. But for simplicity we are not writing this. So here we can write R. R is your 10 plus or minus delta R is 0.7. This much ohm, as resistance unit is your ohm. Now this is the question answer of your previous part. Now there is another formula related to your error, that is the last one, and the formula is suggesting, suppose Z is a physical quantity which is a to the power n. Means a is used n times the product of, means a n times it is multiplied to give rise this physical quantity. So in that case, if you are asked to calculate the the error part here, the formula is suggesting, just remember, the proof also you can do in the similar way. The formula is suggesting the relative error in Z, that is del Z by Z, is nothing but n times the relative error in A. It is one formula. Got? Del Z by Z is equal to n times del A by A. So we can use this formula frequently. You can prove it in the similar way. You can prove it. Now suppose one question is given. Suppose we know the volume of a sphere is given by P is equal to 4 by 3 pi r cube. Got? the question is asking here, the question is asking find out the error, find out the percentage error in the measurement of volume if the percentage error in the value or in the percentage error in the measurement of the radius of the sphere is, let's say, 0.2%. Got? The question is here the percentage error in measuring the radius is given by 0.2%. So find out the percentage error in measurement of V. Our formula is suggesting as 4 by 3 pi is a constant, V depends on this R cube. Here R is a measurable quantity, we can measure R. So the error will lie here, not here, it is a constant. So while calculating our error part, the constants we need not consider the constants in our calculations. So according to our formula, we can omit it. So V is depending on R to the power 3. So basing on this formula means here A stands for R, N is equal to 3. So according to our formula, del V by V is nothing but 3 into del R by R. So if you multiply 100, then both sides will be percentage error. So which implies here we can write del V by V percentage error must be equals to 3 into del R by R percentage error. So but in our data it is given del R by R percentage error is 0.2%. Now this percentage error we can calculate, that is 3 into 0.2, which is 0.6 percentage error will appear while calculating the value of the volume of the physical quantity, of the volume of the sphere. Okay, thank you.